Okay, so section 5.5, solving trig equations. So we've seen identities and graphs and definitions. Now we're going to be able to solve trig equations. So how do we go about doing that? First off, how do you tell if something's a solution to a trig equation? Well, plug in the angle and find out. So is pi over 2 a solution to this equation? Well, plug it in. Put a little question mark over the equal sign because we don't know if pi over 2 is a solution. Right? And so to tell whether or not that is a solution, we have to simplify this stuff inside the sign, if we can figure that out. So minus 1.5, is that equal to 3 times the sine? Well, 3 pi over 2 plus pi over 6. 3 pi over 2 plus pi over 6 is actually 5 pi over 3. A little bit of simplification can get you that, because this is 3 pi over 2 is 9 pi over 6, so the whole thing is 10 pi over 6, which is 5 pi over 3. Well, what's sine of 5 pi over 3? Well, that's one of the, I don't have a whole lot of space, but we'll put a little circle here. Here's my unit circle, 5 pi over 3. Well, 6 pi over 3 would be 2 pi, so 5 pi over 3 is down here. So my angle is 5 pi over 3. And so that means that my sine of 5 pi over 3 is minus square root of 3 over 2, because it's the y coordinate. And if this is a 60-degree angle, then the y coordinate is minus square root of 3 over 2. And so my right-hand side is actually minus 3 square root of 3 over 2, which is not equal to minus 1.5. So what do we do with our question mark? Put a big X through it. Pi over 2 is not a solution to that. What about minus pi over 9? Well, same thing. To check if something is a solution to an equation, you plug it in and see if you get a true statement. Right, so we've plugged it into the sign. Now we need to simplify what's in the sign. This becomes just minus pi over 3 plus pi over 6. And if you add those together, you get minus pi over 6. And the sign of minus pi over 6, well, that's actually minus 1/2. And so our equation becomes minus 1.5 equal to minus 3 over 2, and that is in fact equal. So we give it a big check mark. Yes, this is a solution. No. Okay, so how do you tell something is a solution? Plug it in. So example 1, illustrated with a graph. What are other solutions? So minus pi over 9. Well, this is the graph. The green thing is the graph of the, let's see, right-hand side. Right, so that's y equals 3 sine 3t plus pi over 6, and we learned a little while ago about how to graph those by hand. We know that 3 cycles every 2 pi, and it's been shifted a little bit. And the amplitude is 3. So cycle starts here. You got 1 cycle there, then 1 cycle to here, and then a 3 cycle to here, and that whole thing from here to here, it's 2 pi. So we found one solution. Oh, and this is the right-hand side. This is minus 1.5. Y equals minus 1.5. So the solutions we're looking for are what are the x coordinates of these points where the line intersects the function. We found one. That's minus pi over 9. But what are the other ones, and how can we find them? And we'll see that in a little bit. But to be able to do that, first thing we need to do is to learn how to solve sort of basic trig equations. So basic trig equation is just something like sine of t equals 1/2, right? So nothing special, just a function. So sine of t is the red curve, and the blue curve is the constant line y equals 1/2. So we want to know what is this point and that point, this point and that point. There's infinitely many, and you can see by the repetition of it, sine is one cycle from 0 to 2 pi. So if I can find this point and add 2 pi to it, I should get that one. If I add 2 pi to that one, I'll get this one. And if I add 2 pi to this x coordinate there, I'll get that one. And likewise, if I add 2 pi to this, I'll get that point, and you can get a string of other solutions. And going backwards, if I subtract 2 pi from this solution, I'll get that solution. So to solve a basic trig equation, you need to find the two solutions that are between 0 and 2 pi, and then you can just add multiples of 2 pi to them to get the rest. So here's a blow up of that. Here's y equals sine of t. The blue line is y equals 1/2. And there's a solution here and a solution here. Those are my two solutions I'm looking for. It's kind of a wonky graph, right? My x-axis would be in here somewhere, right? And this is from 0 to 2 pi. So I need to find these 2 points. So how do I find those? Well, we just go to our unit circle. Here's our unit circle. Sine of t equal to 1/2. Remember that sine is the y coordinate on the unit circle. So there's two angles. One is here, and the other one is there. So two angles to give me sine of t equals 1/2. So sine of t equals 1/2 has two solutions. T equals, well, 1/2 we know is part of a 30, 60, 90 triangle. So this is pi over 6. And we know that this angle is also pi over 6. So the angle that we're looking for that's between 0 and 2 pi, which is this angle, that's going to be pi, because that's the angle from 0 all the way to the negative x-axis, minus pi over 6, which is 5 pi over 6. So two possibilities. Those are our two solutions, pi over 6 and 5 pi over 6. So what are the rest of my solutions? What's this one, for example? Well, that's going to be pi over 6 plus 2 pi. We take this and we just add 2 pi to it, and we end up there. What's the rest of them? Well, this is pi over 6 here. So pi over 6 plus 2 pi, pi over 6 plus 4 pi, pi over 6 plus 6 pi, pi over 6 plus 8 pi. And this one is 5 pi over 6. So 5 pi over 6 plus, this one should be going here, 2 pi plus another 2 pi, that's 4 pi, 5 pi over 6 plus 6 pi, 5 pi over 6 plus 8 pi, however many there are. So we summarize that. By saying that the solutions are pi over 6 plus 2 pi n, where n could be any integer. So pi over 6 plus, if you take n equal to 100, pi over 6 plus 200 times pi is a solution, because pi over 6 plus 200 pi means go pi over 6 up here and then go around the circle 100 times, and then you end up here. So sine of pi over 6 plus 200 pi is 1/2. So when you have sine equals to a number, there's going to be two solutions, one on the right side of the circle and one on the left side of the circle. Okay, so what about an equation like this? 6 tangent of t plus 1 equals 2 tangent of t plus 5. This is the same kind of thing, because if we gather, the goal here now, if you have an equation like this, is isolate the trig function. So I'll subtract 2 tangent t from both sides, and that gives me a 4 tangent t on one side. And then I'll subtract a 1 from both sides, so that gives me a 4, and then I'll divide both sides by 4, and that gives me tangent of t equal to 1. So this green curve is tangent of t. It repeats these shapes. And the blue curve, so all these graphs are tangent of t. And then the blue curve is y equals 1. And we're looking for all these points of intersection. And what do we know about that? We know that if I have a 45, 45, 90 triangle, right, then the two sides here are the same length. They're both 1 over square root of 2. So tangent of pi over 4 equals 1. Is there another solution to that? Sine had 2 solutions. Tangent also has 2 solutions, but they're actually very conveniently located relative to each other. This triangle down here has 2 sides that are the same length, and they're both negative. So when you take minus 1 over root 2 divided by minus 1 over 2, you get 1. So tangent of 5 pi over 4 is also equal to 1. What's the relationship between those two angles? You just add pi to it. So pi over 4 plus pi, that gives me another angle with the same tangent. So tangent has period pi. And so this is pi over 4. If we add pi to that, we get 5 pi over 4. If we add another pi to that, we get 9 pi over 4, etc. So what are all the possible angles? Pi over 4 plus n pi, where n is any integer. So can you solve these things using trig, using inverse trig functions? So suppose we want to use an inverse trig function to solve cosine t equals 1/3. So the blue curve here is y equals cosine t. The black line is y equals 1/3. We see there's one solution here, and there's one solution here, and 2 pi is here, and this is 0. So this is one cycle of cosine, and there's 2 solutions in there. So if you have cosine t equals 1/3, and you use your inverse trig function, it will tell you, and your inverse trig function is in radians, it will tell you that t is about 1.23 radians, which is about 70 degrees. Okay, so that tells me which solution does it actually give me. Well, that's this one. Inverse trig function will give you one of the 2 solutions. You have to figure out where is the other one. So let's think about the geometry of cosine a little bit. Cosine is the x. So if I draw my unit curve, unit circle, about, here's an angle of about 1.23 radians, right? And that gives me this length here is 1/3. So that's an angle whose cosine is 1/3. What's another angle that's got a cosine of 1/3? That would be down here. So this angle here also has angle cosine equal to 1/3, and that's just the reflection in the x-axis. So that would be minus 1.23 radians. So cosine t equals 1/3 tells me that t equals 1.23 radians, more or less, plus 2 pi n. Or t equals, well, we want to be careful here, right? Because that's a negative number, and we want to have a positive number because we want solutions between 0 and 2 pi. That's our base cycle. So what angle is that? We go all the way around looking for this angle. We know the entire angle is 2 pi. So our second solution is 2 pi minus 0.23 radians. That gives me this angle, and that's about 5.05 radians. Now, if we're doing everything in degrees, this would be about 70 degrees plus 360 times n, because all the way around the circle once is 360 degrees, all the way around the circle once is 2 pi radians. So this would be about 5.05 is about 289.47, call it 290, plus 360 n. And that gives you your solutions. Okay. So kind of run out of space there, but I'm going to move this down a tad so I can draw a little picture. So what do we see in dealing with sines, cosines, and tangents? When you're trying to solve for sines, if this is one angle that's got the sine that you're looking for, then the other angle is over here, and it's just flipped over the y-axis. So this is sine. So sine of t, which is this angle, and sine of pi minus t, which is this angle, have the same sign. So those are the two solutions you are looking for. If we're looking for cosine, well, cosine is the x. So if this is my angle t, then, well, this is minus t, so this whole thing around here is 2 pi minus t. So cosine of t and cosine of 2 pi minus t have the same solution. Sine is reflection about the y-axis, cosine is reflection about the x-axis, and then tangent if this is an angle, sorry, that should just be a t. If that's an angle that gives you your tangent that you want, then the other angle is this one, which is t plus pi. So tangent of t and tangent of t plus pi have the same tangent. So that's how you get, if you know one solution, you can get the other solution. So now we'll go back to the original equation that we had, which is what are all the possible solutions to this? We knew one solution started off at minus 1/9. And if we look at entire cycles, here's one cycle. And inside that cycle, there are two solutions. So how can I get my hands on, oh, that's not minus 1/9, that was minus pi over 9. How do I get my hands on these two solutions? Well, there's something a little bit complicated inside of the sign. So the first step I'm going to do is make a substitution. Whatever is that's inside the sign that's a little bit complicated, let me just pull it out and rewrite it as u. So that gives me this equation. Minus 1.5 equals 3 times sine of u. So what is u? Divide both sides by 3, you get minus 1/2 equals sine of u. And that's sine of something equals minus 1/2. There should be two solutions, right? If minus 1/2 is here, we should have one solution there and one solution here. And we know that this angle should be pi over 6. And this angle also should be pi over 6 because 1/2 is the opposite in a 30, 60, 90 triangle. Which means, what are the two angles we're looking for between 0 and 2 pi? That is 5 pi over 6. Oh, sorry, 7 pi over 6. Right? So u would be from here to there is 6 pi over 6 gets you to the negative x-axis plus an extra pi over 6. And the other one is, well, that's 12 pi over 6 minus 1 more pi over 6, 11 pi over 6, plus 2 pi n. So those are all my solutions for u. And we'll just substitute back in this thing for u. So I have 3t plus pi over 6 equals 7 pi over 6 plus 2 pi n. Subtract a pi over 6 from both sides. It gets you 3t equals pi plus 2 pi n, right? 7 pi over 6 minus pi over 6 is just pi over 6, and then divide by 3. And we get that. What's the other solution? The other set of solutions? 3t plus pi over 6 equals 11 pi over 6 plus 2 pi n, and that's supposed to be a pi there. Subtract your pi over 6, and you get 5 pi over 3 plus 2 pi n. You subtract a pi over 6, you get 10 pi over 6, which is 5 pi over 3, and then divide through by t. Great, so there's all our possible solutions. We've actually figured them all out. So this is actually pi over 3. And the other one that we found is 5 pi over 9. And this one that we found earlier, we checked earlier, that's 5 pi over 9 minus 2 pi over 3. You do the math there, you get minus pi over 9. And that's because we went 1, oh, I forgot to have an n here. We went 1, 2 pi over 3, which is the length of the period of this function, to the left. So from here to here is 2 pi over 3. That's because of the 3 there, right? 3 cycles per 3 cycles per 2 pi, and then another 2 pi over 3 there. And this one, an extra 2 pi over 3 will take me there, an extra 2 pi over 3 takes me there. So how many solutions do I actually have between 0 and 2 pi? I've got 1, 2, 3, 4, 5, 6 solutions between 0 and 2 pi. 3 that are pi over 3 plus 2 pi's over 3, and then 3 more that are 5 pi over 9 plus 2 pi over 3. Great, so that's that problem. What about this problem? A little more complicated because we don't have just cosine equals something or just sine equals something or something that we can reduce to just cosine equals something or just sine equals something. So why can't we cancel? It looks like we should be able to cancel out the cosine t's. We cannot cancel because you can't divide by 0. And you can never cancel if the thing you're canceling by might be equal to 0. So how do we handle that? Well, we'll factor instead. Usually if you can't cancel, you can factor. We'll bring the cosine of the 3 cosine t over to the other side. And that gives me that equation. And now I can factor out the cosine t. And we have that. And so now we need to figure out what exactly are the solutions here. Well, if I have two things multiplied together to give me 0, either cosine t equals 0 or sine squared of t minus 3 equals 0, excuse me. This one is easier to deal with. That's got no solution. Because sine squared, well, sine is always between -1 and 1. Sine squared is always between 0 and 1. So if you graph it, you get a function that goes up and down between 0 and 1, but it never gets up to 3. So there's no solution to that. This has got solutions, though. Right? And what's the solutions to that? Well, we draw a unit circle. Cosine t equals to 1. That's right there. Right? In fact, there's only one solution for cosine t equal to 0, and that's t equals 0. There's only one solution between 0 and 2 pi, and that's t equals 0. But 2 pi, 4 pi, 6 pi, etc. These are all solutions, and t equals 2 pi n. For n, any integer is the solutions that we have. So why is canceling a problem here? Well, if you cancel the problem actually turns out to be solve for cosine t equals 0. If you just canceled the cosines, what would you end up with? You'd end up with no solutions. You would have canceled out all of your solutions. So never cancel something that might be 0. Factor it instead. Okay, what about this one? This is a little bit trickier because now we've got a sine squared and a sine, and so it's not just one sine, so how can we solve this? And here, the quadratic formula will come to our rescue. And remember what the quadratic formula is: x squared plus bx plus c equals 0 means that x is negative b plus or minus the square root of b squared minus 4ac all over 2a. And apparently there's a song that goes along with that, and if you Google that on YouTube, you could probably find it, but I don't remember it. So how can we use the quadratic formula to help us with this? Well, we'll take this formula and we'll rewrite it so that it's equal to 0, because the quadratic formula needs everything to be equal to 0. So we'll write it as 2 sine squared t minus sine of t minus 1 equals 0. Move these over to the right side. And I'm going to do another substitution. I'll take this whole thing, the sine t, that's the thing that's being squared, and then it's by itself, and then there's a constant. So I'll take u to be sine squared, and then this becomes a little more familiar looking as a quadratic equation. It just becomes that. And you can solve that using the quadratic formula. What is u equal to? U is equal to negative b, so that's a positive 1, plus or minus the square root of b squared, so minus 1 quantity squared, minus 4 times 2 times minus 1, all over 2a, so that's all over 4. So what do we get inside our square root? We have a 1 there, minus 4 times 2 is 8, minus times minus is plus, so plus 8, that's all inside my square root, all over 4. So we can solve that. U equals 1 plus or minus 3, as 1 plus 8 is 9, square root of 9 is 3. So we have two choices for u. U equals 1 plus 3 is 4 over 4, which equals 1, or u equals 1 minus 3, which is minus 2, minus 2 over 4 is minus 1/2. And then we'll go back up here. So what is u equal to? U is equal to sine t. So u equals 1. If we substitute back in, we get sine t equals 1. U equals minus 1/2. If we substitute back in for u, we get sine 2 equals t equals minus 1/2. And we can solve these. I think sine t equals minus 1/2 we've already solved a couple of times. Well, at least once. So sine t equals minus 1/2 has solutions t equals, was it 7 pi over 6 plus 2 pi n, or t equals 11 pi over 6 plus 2 pi n. That takes care of that set of solutions, but we have another set of solutions that comes from this. Sine t equals 1. So how can I solve sine t equals 1? Well, draw a unit circle. Where is sine t equal to 1? That's up there. So t equals pi over 2. And of course, there are always infinitely many solutions because you can go around the circle as many times as you want, plus 2 pi n. And so that gives you all the solutions. There's actually 3 families of solutions. There's this one, and this one. And if you graph this equation and set it equal to 0, so if you graph the left side of this, you'll find that it's got 3 x-intercepts, 7 pi over 6, 11 pi over 6, and pi over 2. Okay, what about identities? I know everybody loves identities. So how can you use identities to solve equations? Well, here's an equation. Now the problem here is that we've got cosine times sine. Everything we've dealt with before either had cosine or had sine or had a tangent. Now we've got a mixing together of functions. So one of the identities we have is that sine of 2t is equal to 2 cosine t sine t. So what's 4 cosine t times sine t equal to? Well, that's 2 times 2 cosine t sine t, which is 2 times sine of 2t. So my equation, this is just simplifying the left-hand side. That's using my identity to simplify the left-hand side. My equation now is 2 sine 2t equals 1. So we want to solve sine 2t equals 1/2. So this blue graph is y equals sine 2t. The black line is y equals 1/2. We're looking for these 4 solutions because we're asked to find them between 0 and 2 pi. 0 is here and 2 pi is here. Note that we're dealing with sine 2t, so that means 2 cycles in 2 pi, right? One starts here and ends there, and then we have another one that starts here and ends there. So what do we know about that? If we can find this, and we can find this, then if we add pi, we should end up with that one. And if we add pi to that, we should end up with that one. Because each cycle has length pi. So if I just take this first cycle and move it to the right pi units, I can get the others. So how do we solve sine 2t equals 1/2? Well, we've done this before. So we'll take this over here. We'll just say u equals 2t. That's the thing inside of the sine. So sine of u equals 1/2. We solve that. U must be equal to pi over 6 plus 2 pi n. Or the other solution is u equals 5 pi over 6 plus 2 pi n. And these solutions become 2t equals pi over 6 plus 2 pi n. 2t equals 5 pi over 6 plus 2 pi n. Why is that? Well, u is equal to 2t. So if I replace these u's with the 2t's, I get that. And then finally, that gives me t equals pi over 12 plus pi n. T equals 5 pi over 12 plus pi n. Those are all my possible solutions. But you always got to answer the question that was asked. The question is, what are the solutions between 0 and 2 pi? So we found two of them. This is pi over 12. This is 5 pi over 12. So this one must be pi over 12 plus pi. That's 13 pi over 12, because we're just adding 12 pi over 12s. And this is, if we add 12 pi over 12 to 5 pi over 12, we get 17 pi over 12. So there's our 4 solutions to our equation between 0 and 2 pi. And finally, what about this one? Oh, still got a cosine, I've got a sine. How can I solve this? Well, we know that cosine squared t is equal to, plus sine squared t equals 1. We're dealing with identities. We often want to look for cosine squares and sine squares because we can swap them out for each other. So cosine squared t equals 1 minus sine squared t. And that tells me then that if we plug that back into the equation, we get 2 times 1 minus sine squared t plus 3 times sine t equals 0. Multiply this out, you get 2 minus 2 sine squared t plus 3 sine t equals 0. Going to multiply everything through by a minus sign just to have a positive coefficient on the sine squared. And that's a t in there. Great, so there's my equation. And again, I look at this and I think this is something squared plus something plus a constant. That's a quadratic. We can set u equal to sine of t. And then this becomes 2u squared minus 3u minus 2 equals 0. And then we can solve this for u using the quadratic equation. 3 plus or minus the square root of b squared, which is 9, minus 4ac. So minus 4 times a is minus 8, times a minus 2 is actually a plus 16, all over 4. Nine plus 16 is 25, and square root of 25 is 5. So we have two possibilities. One is u is 3 plus 5 over 4, which is 8 over 4, which is 2. Or u equals 3 minus 5 over 4, which is 3 minus 5 is minus 2, u equals minus 1/2. So plug back in what u is equal to. So we have sine of t equals 2, or sine of t equals minus 1/2. This has no solutions. Sine is always between minus 1 and 1, so it's never equal to 2. This we've done a couple of times. This is our old friends, 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. And so that's how you can solve these equations. Remember that cosine and sine always have two solutions in between 0 and 2 pi. In general, cosine and sine have two solutions in every cycle. If you have multiple cycles in 2 pi, right, then you get multiple solutions. And keep in mind the symmetries involved. Where's my symmetries? Boop, boop, boop. There they are. If you know what are the relations between the two angles that have the same sine value, they're reflected across the y-axis. Two angles that have the same cosine value are reflected about the x-axis. Two angles that have the same tangent are reflected about the origin. And so that is section 5.5.